Today we are going to talk about the change in concentration over time. And we are going to link that change in concentration over time with the rate of a reaction. For example, if we have a reactant X, the rate with respect to X will be the concentration of X at time T2 minus the concentration of X at time T1 all over T2 minus T1. And this can be written like what I just indicated here, to say everything should be equal to the change in concentration of X over change in time. And now the units of concentration, sometimes it can be indicated like this one here, whereby it's in mole per liter or mole per decimeter cube, like that. So now I want to graphically show you how this reaction proceed in terms of what transpired from the reaction state all the way to the product with the help of this graph here. I want you to look at this graph like this. So obviously this is the y-axis, this is the x-axis. So now normally if we have a product, it will normally start underneath here and go up like this, and then the reactant is the one that will be curving down and going down like that. So now when the reaction started, let's say for example this is concentration, right? If we are talking about concentration of A, this is time on the x-axis, then you will realize that at time 0 there is no product yet, meaning that the graph for the product will normally start at 0, and as time proceeds it will curve up like that all the way to give us a certain product. Then when we get that product, you will realize that what's happening when we get the product, the reaction itself, it's going down like that. Can you see it's curving down like that, the reaction. So I want you to, let me write the reactant. So the reactant, in other words, it is consumed. So I want you to note it down to say the reactant is the one that is consumed. Then the product is the one that is formed. So in other words, we normally talk about the consumption and the formation as far as the product and the reactant is concerned. When you see it curving down like this reaction, I want you to think about something that is going down, something that is decreasing, something that is associated with negative or losing of some sort. I want you to think it in that manner. Then the product one, think it like something that is more like gaining or curving up or increasing, or see it as something that is associated with positivity in that manner. So that's what I'm trying to say as far as the product is concerned. So differentiate these two. I will give you the example with a reaction and the product, and then we should be able to apply that one. Let me find this space here so that I can show you exactly what I'm trying to say, or what message am I trying to drive at as far as this concept is concerned. So now I want you to look at this kind of reaction. Let's say for example we have A reacting with B to give us C reacting with D, like that. If you check that reaction out, you will realize that this reaction, it has this as a product, and we have these two as the reactant. So now I mentioned to say the reactant, when we started, they are normally on top, right? and they curve down. In other words, they are the one that are consumed, right? But the product is the one that is formed. So now, if we were to find the rate of the reaction, how will the rate of the reaction look like? In other words, the rate of the reaction can be defined using the general formula that I want to show you here. So the rate of the reaction can be defined using the general formula, and the general formula will go like this to say the rate, let's start with this one here, the rate of this one will be equal to negative 1 over A over dt. So I want you to analyze what I wrote here and analyze how did I come to that conclusion to say it will be like this. And by the way, either A, B, C, D are the species coefficients. Like this, A, B, C, D are the species coefficient. So if you check it out, this one, the rate for this one, it is negative because it is consumed. You can even see it here, curving down, right? So now, what about the one for B? The rate for B will be equals to negative 1 over B dB all over dt, right? Because it is still a reactant, and the reactant are the one that are consumed, and when they are consumed, they curve down like that. They are associated with a decrement. What about the one for the product now? The one for the product, you will find out that we are going to have a rate being equals to, it will be positive 1 over C D C over dt. What about the one for D? This one here for D, the rate, you can pause the video and write this one. What will be the answer? It will be 1 over D what? dd over dt. So now if you check it out, there is different, the different is the sign actually between the reactant and the product. The one for the reactant, we have a negative here, right? We have a negative. This negative is just simply there to indicate that somewhere, somehow, something is being consumed there. And when it is consumed, the product, it is formed. So now I want to erase this this equation, these are rates, and now give you another formula whereby you will tell me what will it look like. In other words, we are going to remove this coefficient and write something else and work it out. So let's do that quickly. Let's now suppose that let me erase this one quickly. Yeah, so after I erase this one, I will now write the equation. Let's say we have the equation just that look like A plus 3B to give us C plus 5D. Let's look at it in this manner. So what will be the rate? Obviously, as far as A is concerned, you can pause the video and work it out. The rate is equals to, we have 1 here. It's just that we don't write this one, right? It will be 1 over 1 from this part, right? Then after 1 over 1, it will be dA over dt. It will be like that for this first one, right? However, there should be a negative here. Where is this negative coming from? From the fact that it is the reactant and it is consumed. It is the one that has been consumed. So it comes from that one. From there, for B, the rate will be equals to negative 1 over 3 dB over dt. Why negative? Because it is still at a left-hand side. Remember, the left-hand side is the reactant, the right-hand side is the product. So the reactant is being consumed, it is associated with the negative. So it's going to be 1 over 3 dB over dt. What about now for the product? Obviously for C, it's going to be 1 over 1 dC over dt, right, for this one. What about for the last one? The rate for the last one will be 1 over 5 d what? dd over dt. If you check it out on the product side, we don't have negative here. We don't have negative. Why? Because this one I mentioned to say, when I explain this graph, think about it in this manner so that you won't forget. When we started, the product is at 0, but somewhere, somehow, it is associated with gaining or formation of something, or curving up, or increasing. It is associated with those kind of things. So that's why we write it like that, with a positive like that. So now, this is very important. I want to write one, let me create a space and write one reaction, one example, and do one example. Maybe you will understand it better after this kind of important example. So in the meantime, you can be thinking about something of this nature. I will write a certain equation that you can now use it as an exercise. So you will comment your answer at the description, at the comment section below. All right. So consider this equation. Let's say you have a reaction like this, 2A plus B to give us C plus D. No, let's say plus 3D, like that. So let me write it nicely. Plus 3D. Yeah, write the rate. How will the rate look like? So when you do that, I will be writing the equation. As you're working that one out, I will be writing another question here. So this question goes like this. The rate of the reaction, the rate of the reaction, what reaction? The reaction goes like this. It's A plus 3B to give us C plus 2D. So the rate was reported as the rate was reported as 1,0 mole per decimeter cube per second, right? State the reaction rate. Now the question says, state the reaction rate. State the reaction rate. Actually, state the rate of the formation and the rate of the consumption. Sorry. State the reaction rate of the formation and consumption of the participant. Of the formation and the consumption of the participant. Of the participant. So I want you to take this moment and think about this question like this. If we check it out, we talk about the formation of the we talk about the formation and the consumption. So the question says, find the formation and the consumption of the participant. What are the participants? First participant, second participant, third participant, fourth participant. So all these are our participants, right? So now, in order to find the answer for this, we know the rate. What will the rate look like? So for this one, please, I want to believe by now you should be done writing the answer for this. When you get the answer for this, please comment your answer on the comment section below. Then we should be able to work it out like that. Now, what we are going to do when you have something of this nature is that we are given the rate, right? Remember, the rate for everything should be 1 mole per decimeter cube per second, right? But you want to find the one for each participant. So how do we do that? Allow me this time around to say, this is the answer, to say V for the rate, to say rate should be equal to what? For this one, the first one, we said we associated with, obviously, with negative 1/1. However, this negative is just indicate that is the one that has been consumed, right? If we use the language of consumption and not we use the language of talking about consumption and formation, sometimes there is no need to include the negative and the positive, because it just indicates that is the consumption and the one for formation, it should be positive. So it should be 1/1, what? With respect to A, it will be dA over dt, right? Then this also should be equals to, what about for this one? It's going to be negative 1/3, what? dB over dt, right? What about for this one? It's still going to be equals to 1/1 dC over dt, which is also going to be equals to what? What about this one? 1/2 d what? dd over dt, like that, right? Everything should be equals to, we are given, remember I said V is the rate, right? This V is the rate, we are given the rate, so everything should be equals to 1 what? 1,0. The units should be mole per what? Per decimeter cube per second. It should be like that. So from there, you will come now and say, we are now focusing now on the what? On each participant, right? So the participant, the first participant is A. So A is not a consumption, it's not a formation, it's a consumption. So we'll say the consumption of A, we'll do that like this. The consumption of A is equals to, what will be the consumption of A? The consumption of A, if you check it out, we have only dA over dt being equals to 1. So this means it will be 1 mole per decimeter cube per second. So that one is the consumption of what? Of A. Now, what about the consumption of what? Of B. So we will now come again and say what? The consumption of B. Remember, B is not from this consumption because it's from the what? It's from the reactant. The consumption of B will be equals to, let's check it out. We are relating this one and that one, right? The rate is this part here, right? This is the rate that we are talking about, right? So we have a problem here because we have this one here, right? So we'll have no choice because we are relating this one and the final one, right? So we'll multiply here by 3, so that 3 will cancel 3, and we multiply here by 3 here. At the end of the day, we are going to find the consumption being equals to 3 mole per decimeter cube per second, like that, right? So because we have that one. So what about now the formation? Because C is a formation, right? It's not a consumption. So now for C, we will write and say the formation of C is equals to, the formation of C, we come and look at here. Remember, this is the rate, right? This one, 1/1, it will still be 1. Any number multiplied by 1 is that number. So when we relate this one and that one, the formation of C, the answer will be just like 1 mole per decimeter cube per second, right? Then the last one, let me write it here, which is the formation of what? Of D. Remember, D is in the product. On the product, we talk about formation. On the reactant, we talk about the consumption, because the reactant is the one that is consumed. So we'll now say the formation of what? Of D will be equal to what? The formation of D. We will relate this one and this one, right? So the rate is this one, but we have a problem of this one. So we'll multiply by 2 this side and multiply by 2 here, and we find that the formation will be equal to what? To 2 mole per decimeter cube per second, like that. So in short, that is how we find the rate of consumption or the rate of formation.